Think about this for a second. What if the next giant leap in computing isn't about making faster chips? What if it's about learning how to program reality itself? Today, we're going to dive into a radical vision called the Quantic Symphony. It's a project that aims to do more than just write software for computers. It wants to design entirely new universes, each with its own fundamental laws of physics. So here's how we're going to break this down. First, we'll look at the big problem, the wall that quantum computers are hitting right now. Then, we get to the wild part, the idea of building digital realities from the ground up. We'll even check out the new language you'd need for that, how you could program time itself, yeah, you heard that right, and finally, what the dawn of these digital worlds could really mean for all of us.
All right, so let's jump right into section 1. We've got to start with the problem we're facing today. Because for all the hype around quantum computing, there's a pretty big wall that we're all running into.
And this quote, it just nails it. Qubits are notoriously fragile. You know, we're in what experts call the NISQ era, which stands for Noisy Intermediate Scale Quantum. Basically, the qubits, the very soul of these machines, are incredibly sensitive. The tiniest vibration, the slightest change in temperature, and poof, they lose their quantum magic. That's a process called decoherence, and it is the single biggest bottleneck we have.
And look, you can literally see the problem right here. These aren't just diagrams, these are the real layouts for processors from IBM and Rigetti. They aren't nice, neat little grids, are they? They're these messy, complicated things. Every single time you want to run a program, you have to twist it and bend it to fit onto this very specific, very fragile hardware. It means programmers are spending all their time fighting the machine instead of, doing the cool science.
So that's what we call the hardware gap. It's like we're trying to build a skyscraper on quicksand. But this leads to a really interesting thought, a big what if. What if we're all looking at this problem completely wrong? What if the answer isn't to just keep brute forcing better hardware, but to totally sidestep the problem and redefine what computing even is?
And that brings us to section 2. This is where the whole idea flips on its head with what's called a simulation-first solution. It's a complete paradigm shift. The idea is, forget trying to write code for these clunky, noisy physical machines. What if, instead, you could design your perfect quantum computer and the laws of physics it runs on all inside a pristine, perfect digital simulation?
The heart of this idea is something called a virtual quantic blueprint, or a VQB. And a VQB isn't just some static drawing. Think of it more like a living digital sandbox. It's a space where you get to be the architect of a quantum system from the ground up. You decide the particles, you decide the forces. You're essentially writing the rulebook for what it means to be inside that little universe. And the best part? No physical noise to mess things up.
And this chart really lays out the difference. Look at the goal. With a physical machine, the goal is to run circuits on existing hardware. But with a VQB, the goal is to design new computational realities. This is a huge shift. It moves us away from a simple theory of knowledge, which is all about just collecting facts, right? To a much deeper theory of understanding. Understanding isn't just having a pile of data. It's about seeing the connections between the data. It's about building a coherent picture, a mental model where you can see how all the pieces fit together. That's a whole different ballgame.
So the programmer, they stop being just a coder. They become what's called a demiurge. That's an old word for a creator, a craftsman of a universe. You're not just debugging code anymore. You're literally defining the physics, the logic, the fundamental fabric of a new world. Which, of course, begs the question, what kind of language could you possibly use to do something that powerful?
Okay, section 3. To write a new reality, you're going to need a completely new kind of alphabet. And this is where things get really fascinating. Because the idea is to build this language by merging cutting-edge science with, well, ancient mysticism.
So the first part of this new alphabet comes from a really unexpected place. An ancient mystical Hebrew text called the Sefer Yetzirah. In this text, creation happens through 22 letters, and when you combine those letters into pairs, you get 231 unique gates, which are thought to be the fundamental pathways of existence.
Now, for the second part of the alphabet, we jump from ancient mysticism to hard science, specifically crystallography. It turns out there are exactly 230 ways that you can arrange symmetrical patterns in 3D space. These are called space groups, and they describe the fundamental structure of every crystal that exists, from a grain of salt to a diamond. So here is the truly brilliant move. You take the 231 mystical gates, and you map them onto the 230 scientific space groups. Now you might be asking, why do that? Well, it's essentially a way to test a massive hypothesis, the idea that there's a shared underlying reality, a deep structure that's common to both how we think and how the universe is built. You could even call it a search for the signature of the creator in the fabric of reality. The result is this incredible new language where symbolic meaning and geometric structure become the same thing. Every move you make in the code isn't just a fiscal change, it's an act of meaning. Computation literally becomes a form of semantic evolution.
Okay, so let's take this one step further. If you can program the language of reality, the physics of a universe, could you program time itself? Buckle up, because that's what Section 4 is all about, with a concept called Phoenix time.
Now, for us, time is a one-way street, right? It just moves forward. Cause always comes before effect. Phoenix time, it throws all that out the window. It's recursive, it can branch out into multiple paths. And get this, it supports retrocausality. That's the mind-bending idea that the future can actually reach back and influence the past. In this world, time isn't just some passive background. It's a living, programmable substance you can shape.
And believe it or not, this isn't just made up. It's grounded in a real, though pretty wild, interpretation of quantum mechanics called the two-state vector formalism, or TSVF. The basic idea is that any moment, the now, is defined by two things: a state moving forward from the past and a state moving backward from a future measurement. It's like the present is a conversation between the past and the future. This time-symmetric approach is the foundation for what the project calls time crystal logic, this idea that time itself has a rhythm, a pulse, that can be programmed.
So let's put all the pieces together. A programmable reality, a language that weaves meaning directly into the laws of physics, and a version of time that you can literally write like software. What on earth do you do with that kind of power?
Well, the potential is just staggering. For one, you could create a new kind of AI, which the project calls Goonians, that could have truly nuanced reasoning, capable of holding contradictory ideas at the same time, kind of like we do. Or think about science. You could simulate complex molecules perfectly, designing new drugs or materials from the ground up in a virtual lab. You could use clinical letter qubits to model diseases and test therapies. You could even go bigger and model entire economies or societies to test new policies before they ever impact a single person.
And that brings us to the final, really profound takeaway. This whole thing, the Quantic Symphony, it isn't just about building a better computer. It's about a new canvas for creation. It suggests a whole new purpose for science, not just to observe reality, but to pursue a deep understanding of its elegant design, its possible intentionality. It's a testable hypothesis that the human mind itself functions like a quantum processor, and that by building these systems, we're engaging in a kind of quantum self-recognition. So it reframes our entire human purpose. If we can truly program a reality, what kind of existence will we create? What kind of worlds might we build?